This is the Sophomore A News. Our feature story today is that a group of students, some of the best students of this section, have created a very informational and great video about the group Halogen. They have gotten many experts around the world and around the school just to talk about and to describe and go into this new unknown world of halogen family. The halogen group is made up of 5 nonmetallic elements found on group 7 in the periodic table. Fluorine and chlorine exist as gases, bromine exists as a liquid, iodine exists as a solid which gives off a purplish gas, while astatine exists as a solid.
They all have 7 valence electrons, which give them an oxidation number of -1.
Halogen means salt former. This is why they form salts when they react with metals.
Now let's start going into the different elements. Our first element is called fluorine, denoted as a capital F. Its atomic number is 9, while its atomic mass is 19. It has a melting point of -219.62 degrees Celsius and a boiling point of -188.14 degrees Celsius. It has a high reactivity and a strong bond to other elements except helium, neon, and argon. It is the most chemically reactive and electronegative element of all.
Why do you think fluorine is used in toothpaste and other substances to fight against dental decay?
Fluorine has content that can cause prevent demineralization, meaning when the cavities in the tooth, it can stop it from progressing. And it can promote remineralization so that, the tooth decay can be arrested. Okay? So it can also act as an antibacterial agent that is found in that it can go to your saliva, that it can help prevent tooth decay.
Here's the pale yellow and brown gas in room temperature. It also has an ionization energy of 174,228. It may be highly electronegative, but it is a weak acid. Hydrofluoride is a weak acid due to the fact that the fluoride ion is basic.
Fluorine is commonly used in toothpaste, rocket fuel, refrigeration fluid, and etching solutions. It is sometimes artificially added to municipal water supplies to prevent dental cavities. Its compounds and combinations are tested and have proven to be effective against dental decay. They include sodium fluoride, stannous fluoride, sodium fluoride, and amine fluoride. Fluorine is essential for the maintenance of solidity of our bones.
Then how is it relevant when it comes to dentistry?
It's very relevant. We need fluoride. Like some people now come up with other things like sorbitol, xylitol, and stuff like that. But fluoride is still the best in preventing cavities. So that's it.
Fluorine is also used to make hard plastic, just like Teflon, which is used at extremely high temperature.
It is a great source for fuel and energy due to the properties contained within the element. It makes fluorine a highly flammable gas, which makes it good for use of fuel.
The main mining areas for fluoride are China, Mexico, and Western Europe. Fluorine occurs naturally in the Earth's crust, where it can be found in rocks, coal, and clay. As it is the 13th most abundant element in the Earth's crust, it can also be released in the air due to air-blown soil. Hydrogen fluorides can be released into air through combustion processes in the industry. Fluorides that are found in the air will eventually drop into land or into water. It is only when fluorine is attached so small particles could stay in the air for a long time.
Thus, we humans are regularly exposed to fluorine, since fluorine can be found in the ground, air, plants, and animals. They can also be found in the food we eat, since small quantities are found in food. Only tea and shellfish may contain large quantities of fluorine.
Although fluorine is useful in a lot of our everyday activities, there are always possible dangers to it. An example is, if it is absorbed too frequently, it can cause tooth decay, which is ironic since fluorine is used in most toothpastes. It may also cause osteoporosis, harm to the kidneys, bones, nerves, and muscles. It's a very dangerous gas and it can cause death at high concentrations. And at low concentrations can cause nose and eye irritations.
What properties of fluorine or fluoride make it suitable to fight dental decay?
Fluoride ions, even 0.1% only, which we need like 1,000 parts per million in a toothpaste, can help fight tooth decay or prevent cavities in people. So that's why it's really highly recommended. Some people, would say that too much of it can be bad and cause damage to the teeth like fluorosis, but it's not in the fluoride content that can cause that because we need it, but it's in the quantity you're putting. So that's why we usually recommend pea-size amount. And fluoride is good for us. It's been there. It's been used since way back.
Our second element is called chlorine, denoted as a Cl. Its atomic number is 17, while its atomic mass is 35.45. It has a melting point of negative 100.98 degrees Celsius and a boiling point of negative 34.6 degrees Celsius. It is the second lightest halogen following
Chlorine
fluorine.
is mostly used in the manufacturing of chlorinated cleaning compounds, pulp bleaching, disinfectants, and textile processing. Bleach and water disinfections, the most commonly seen compound of chlorine, is common in salt.
It is also used in making bulk materials like bleach paper products, plastics such as PVC. It is also used to make dyes, textiles, medicines, antiseptics, insecticides, and plant paints.
Greenish yellow gas at room temperature and at atmospheric pressure. It is 2.5 times heavier than air and is the second lightest halogen following fluorine. Chlorine is not found uncombined in nature. Halite or sodium chloride or common salt is the main mineral that is mined for chlorine. Sodium chloride is a very soluble salt that has been leached into the oceans over the lifetime of the earth. Several salt beds or lakes are found where ancient seas have evaporated, and these can be mined for chloride.
Acute exposures can result in symptoms of acute airway obstruction, including wheezing, cough, chest tightness, and/or dyspnea. Other workplace studies, however, have indicated that workers exposed to chlorine dioxide or sulfur dioxide have tended to have increased risk for chronic bronchitis and/or recurrent wheezing attacks, like one or more episodes, but not asthma, while those exposed to ozone have a greater incidence of asthma.
Our next element is called bromine, denoted as Br. Its atomic number is 35, while its atomic mass is 80. It has a melting point of negative 7.2 Celsius and a boiling point of 58.8 Celsius.
When added as an ingredient regarding health and economical purpose safe to human touch, it is used in making fumigants, dyes, flame-proofing agents, water purification compounds, sanitizer, medicinal agents for photography, and in brominates, vegetable oil used as emulsifiers in many citrus-flavored soft drinks.
Bromine at room temperature is a reddish-brown liquid. It can evaporate easily, and its toxic fumes can irritate sinuses when inhaled. It's a very reactive element depending on the metal and the element. Bromine is found naturally in the Earth's crust and in seawater in various chemical forms. The chief commercial source of bromine is ocean water, from which the element is extracted by means of chemical displacement oxidation by chlorine in the presence of sulfuric acid through the reaction. When you make human contact with bromine raw, it can irritate your eyes and through inhalation is toxic to your throat. Organic bromines can also cause damage to organs such as liver, kidneys, lungs, and milk, and they can even cause stomach and gastrointestinal malfunction. Some forms of organic bromine even have the ability to cause cancer.
Our next element is called iodine, denoted as capital I. Its atomic number is 53, while its atomic mass is 127. It has a melting point of 113.5 degrees Celsius and a boiling point of 184 degrees Celsius. At room temperature, it appears as a violet solid. Iodine reduces thyroid hormone and can kill fungus, bacteria, and other microorganisms such as amoebas. A specific kind of iodine, called potassium iodine, is also used to treat but not prevent the effects of a radioactive accident.
It is effective for conditions related to too much thyroid gland activity or hyperthyroidism, also radiation energy associated with the use of radioactive iodides, and it is known to be effective against skin infection caused by the fungus Sporothrix.
It's very noticeable in physical and chemical change. Iodine at its solid state is a grayish metal. Once it's turned into a gaseous state, it becomes a cloud of purple smoke. So the world's iodine is found in the ocean, where it is concentrated by sea life, especially seaweed. Many foods are very rich with iodine. Some are sea vegetables, cranberries, organic yogurt, organic navy beans, organic strawberries, raw organic cheese, and organic potatoes. Iodine can cause significant side effects in some people. Common side effects include nausea and stomach pain, runny nose, headache, metallic taste, and diarrhea. In sensitive people, iodine can cause side effects including swelling of the lips and face, angioedema, severe bleeding and bruising, fever, joint pain, lymph node enlargement, allergic reactions including hives, and death.
Do you think that the other elements in the halogen family, in which fluorine is in, would be as effective as fluorine?
With regards to teeth, I don't think so because number one, chemical components like bromine is used in making plastic, so it's toxic. So would be chlorine, which is used to clean up pools, right? So it can be toxic for us to ingest. Iodine is good for the blood, so I don't think it has any effect with the teeth. So fluorine is fluoride would be the best for fighting tooth decay. So it doesn't have the same properties as the other three.
A last element is called astatine. Denoted as At, its atomic number is 85, while its atomic mass is 210 AMU. It has a melting point of 302 Celsius and a boiling point of 337 Celsius. It is actually the rarest naturally occurring element in the periodic table. Astatine is highly radioactive and is only available in tiny quantities. Its properties are inferred from its position in the periodic table and by studying its chemistry in extremely dilute solutions.
Astatine 211 is sometimes used as a radioactive tracer and in cancer treatment. Like iodine, it is known to accumulate in the thyroid gland. Although there are currently only a few uses for astatine outside of research, since the half-life of the most stable isotope is only 8 hours, and only tiny amounts have ever been produced.
Astatine is a highly radioactive element and is the heaviest known halogen. Its chemical properties are similar to those of iodine. Unfortunately, due to their isotopes having short half-lives, little is known about this element. Astatine can be obtained in a variety of ways, but not in weighable amounts. Astatine 211 is made in nuclear reactors by the neutrons bombarded by bismuth-200. Naturally, the world's astatine is found in uranium ore, in pure form. It appears to take on a solid state and it seems to share many chemical properties with iodine, a closely related element.
Astatine is formed by the decay of thorium and uranium, which means it is biologically toxic due to its radioactivity. Like other radioactive elements, astatine poses a human health risk. It can cause radiation damage to cells in people who are exposed to it without adequate protection. Fortunately, consumers like us do not generally need to worry about this danger because of its rarity, and in laboratories, the people who work with the element receive training in handling radioactive substances. And that was the Halogen family. Thank you for watching this documentary. See you next time!